Today we will discuss about the effect of this matrix uh, on this TGF-β induced EMT, that is epithelial to mesenchymal transition. So this is a new paper. We will discuss the first figure, the results that are presented in this figure. So they first check the effect of the TGF-β at different stiffness of the hydrogel. In hydrogel they have used is made up of polyacrylamide. So they have used the hydrogel from 0.1 kilopascal to 60 kilopascal, and they did a TGF-β treatment for 24 hours, and they are able to see that after these 24 hours the TGF-β treated cells are more elongated in nature after this 8 kilopascal. So they considered for this paper considered 8 kilopascal and above as a rigid and 0.4 kilopascal as compliant. So once they are able to see in the elongated kind of structures at kilopascal greater than at stiffness greater than 5 kilopascal, they also confirm whether this TGF-β treated cells in rigid region or in the rigid stiffness has this EMT markers or not. So they did it with this Western blot and the immunofluorescence image for this 8 kilopascals. We can see that the TGF-β treated cells, there is more N-catherines and alpha smooth muscle actin, but there is not much decrease observed in the E-catherine. And similarly, for the case of these immunofluorescence images, they are able to see that the Z01 increases, and E-catherines, TGF-β treated conditions also we can see the signals. Z01 increases, it increases compared to the case where TGF-β treated cells are there. And for the N-catherine, there is a clear increase can be observed for N-catherine, and similarly for this alpha smooth muscle actin, there is an increase, and which indicates that it is transiting to this, it is going through this EMT phase, that is epithelial to mesenchymal transition. Thereafter, they did the Hoechst staining to check the nuclei of both the rigid and compliant. Rigid here it means that 8 kilopascal hydrogel, and the compliant means 0.4 kilopascals. And we can see that from the white arrow shows the fragmented nuclei, indicating that these compliant cells might not be in healthy conditions, and in TGF-β treated conditions they might undergo apoptosis. In order to validate that, at the same time also validate the EMT changes with increase in the stiffness, they checked it for the apoptotic marker, that is Caspase 3, and also for the snail marker, that is also for the EMT marker, that is snail, and they did checked it using the mRNA expressions, their mRNA expressions, and we can see that at the low stiffness the Caspase activities are higher and the snail activities is lower, indicating the cells are more prone towards the TGF-β treatment compared to the case of the cells are more prone towards apoptosis in the TGF-β treated conditions compared to the case where it is treated with BSA. And similarly, when they increase the stiffness, or when they checked these markers with increasing in the stiffness, they are able to see that apoptosis signal goes down and the snail signal goes up in the TGF-β treated conditions. However, there is not much change observed in the non-TGF-β treated conditions. So this plot, that is panel E, indicates that there is a direct correlation. It seems like there is a correlation between TGF-β treatment and matrix stiffness in a way that at low stiffness the TGF-β cause more apoptosis, whereas at high stiffness it will cause the cells to transit towards epithelial to mesenchymal state. This is what they have. This is what they made a point by the end of this figure, that this matrix stiffness has a role towards TGF-β induced epithelial to mesenchymal transition. And that is, at low stiffness it will trigger apoptosis, whereas at high stiffness or in the rigid conditions it will trigger EMT, the epithelial to mesenchymal transition. So that's all for this video. If you need to understand more about their experiments in detail, then go through the reference that has been provided in the description. So that's all for this video. Thank you for your time.